The topic is understanding the concept of Amazon EKS. I will explain you the theory part of it, which is Elastic Kubernetes Service, as well as the project, how I deployed my multi-tier Node.js application ResumeManager in this EKS cluster, which is exposed on the load balancer using the service type NodePort. It is exposed via CloudFront using load balancer for CloudFront. So let's begin. First, let's understand why do we need Elastic Kubernetes Service and why does EKS exist when we have Kubernetes as an open source platform. It's because if you know the architecture of Kubernetes, it has control plane and data plane. Control plane is the brain, meaning EKS is a fully managed service given by the AWS cloud provider, and other platforms also have these services. But if someone doesn't want EKS or fully managed service, they can opt for the open source Kubernetes, and they can do something that is called self-managed, in which you would actually need to do it manually. Meaning what AWS EKS does is it automates the control plane, upgrades, patches, security and operating system, all of this. If someone opts for manual Kubernetes, that is do it yourself, you have to do it yourself by manual setup of etcd, API server, backups, manual node by node sequencing. You have to do the manual operating system hardening and patching. You would need high availability configurations, manual certificate rotation, custom networking integrations, and all of this is a manual process, meaning you have to do it yourself. If you fumble something, you make a mistake, you would ruin the process of creating the control plane of your cluster. Simply, you are preparing your own control plane of your Kubernetes cluster, which is a great responsibility for you to have. If you don't want to take that responsibility and give that responsibility to cloud providers, there exists Amazon EKS. They do the hard work and heavy lifting of doing all of the stuff, and you just use their service to use the control plane and deploy your application. That was the simple, quick introduction to EKS. And let's just begin how I implemented the multi-tier Node.js application ResumeManager on this EKS cluster. To perform this, the first step was to check for the dependencies and the requirements to even perform the AWS concept, EKS concept, and deploying this application. First, I checked if my device or my system has eksctl, AWS CLI, kubectl client. All of this must be present in your device or your system. Also, another thing is that I am not using the console of AWS, meaning AWS Cloud. I'm using a terminal of Git Bash to perform all of this through CLI. So first, I checked if my system has eksctl at AWS CLI and kubectl. My system already had AWS CLI to perform the commands. It was already present. kubectl was already present. eksctl was not present. So it was my responsibility to install and configure eksctl so I can perform and create the cluster and everything. Then I head back into the GitHub of eksctl to download it into my Windows system. I downloaded and I copied and pasted the .exe of eksctl into the tools folder of my local disk, and I added this path into the environment variables, so the system recognizes this application or recognizes this eksctl.exe. Then I confirmed in the CMD terminal the eksctl version. It showed the version of that, which is 0.229.0, meaning it is successfully installed and it is configured for use. Then I already had the configuration YAMLs, but I needed to change it with respect to the EKS cluster configuration. Before it was local cluster, meaning it was kind or minikube. Only one additional YAML is present, which is StorageClass.yaml, and rest are the same YAML of before, but changes related to AWS. Also, I created the folder EKS inside the root of ResumeManager DevOps, and I added all these configuration files. First, for the Ingress configuration YAML file, this is how it looks. Ingress class name is ALB. ALB Ingress is of internet facing, backend service is ResumeManager service, port number is 80. This is the configuration of Ingress. Then this is the configuration of Postgres YAML file, which is the database. Then this is the deployment YAML file of my application. I updated it by adding readiness probe, so my application, when it is running on ports, it has buffer time so it doesn't get crashed. Then there is this service YAML file. DB or database is of ClusterIP service, and resume matches service is of the service type NodePort. Note that you can mention instead of NodePort load balance. Then there is the StorageClass YAML file. It is for elastic block storage persistence volume. It is of the type GP30. I'm using persistent volume, meaning if instances or application breaks down, the data is lost. So I added persistent volume by EBS, elastic block storage. So even if the instance is deleted, if elastic block persistent volume is present, then the data is intact. That was the configuration YAML files. Now it is just CLI and accessing the application. First step is to check if your CLI is configured and connected with your AWS account. To do that, I have used this command AWS space HTS space get caller identity. As we can observe, it showed user ID, account and ARN, which says the username of my account which I am using, which is KF DevOps Admin. Then we are creating the cluster by using the command eksctl create cluster. Name is resume cluster, region is AP South 1, node group name is resume nodes, node type is T3.medium, nodes minimum should be 2, maximum it can be 4, it is managed. Then you can observe that it is creating and it has been created. After the cluster is created, then we must update the kubeconfig. The command is AWS EKS, region is AP South 1, update kubeconfig, name is resume cluster. Why do we need to update the kubeconfig? It is to securely connect our local computer, meaning this terminal, the cloud managed Kubernetes cluster. It retrieves connection data, it fetches the cluster's unique API endpoint, secure certificates. First time attach the required policies. First is EBS CSI policy. The command for it is AWS IAM create policy. Policy name is Amazon EBS CSI driver policy. After EBS driver policy, then it's time to attach the role policy for node groups. To exactly name the node group, I perform this command, that is AWS IAM list roles query roles that contains the role name resume dot role name, that is output with text. So it gave me the result, that is EKS resume cluster service role, and this is the unique number, and another EKS cluster node group. One is service role, another is node instance role. So after I got to know about this exact name of cluster roles, I can now perform the attach role policy on this. The command for it is AWS IAM attach role policy. The role name is, which I just got, I copied and pasted it, and the policy ARN is Amazon SSM read only access. Then for the another policy, it's same AWS IAM attach role policy. Now the policy is elastic load balancing full access. Then AWS Amazon EBS CSI driver policy. After this, I confirmed it with AWS IAM list attach role policies with role name, that is EKS CTL resume cluster node group node instance role. You can observe that the policies have been successfully attached, which is Amazon EBS CSI driver, which is for persistent storage for my database data, and second is Amazon SSM managed instance core, Amazon SSM read only access, elastic load balancing full access, Amazon EKS CNI policy, Amazon EKS worker node policy, Amazon EC2 container registry pull only. I have shown you a few commands before, but you can add all these policies into your cluster node group. So it has required policies, so you don't end up getting restricted or not having access to the commands and working of your deployments in the EKS cluster. Then I confirm the nodes and the pods by kubectl get nodes, kubectl get pods -a. Then we can observe that nodes is on AP South 1 region. There is 2 nodes which we have specified in the cluster, which is successful and it is ready. And you can observe the required system configuration of Kubernetes pods are up and running, which is kube system namespace, AWS nodes, which is 2 nodes which we have specified, core DNS, kube proxy, metric server. All of these are up and running. Then I head back into the VPCs which has been created after the cluster. I copied the VPC ID to perform these commands. Then it was to create add-on. The command is EKS CTL create add-on name is AWS EBS CSI driver. Within the cluster, that is resume cluster, region is AP South. This is same EBS CSI driver for persistent storage for database data. Then this is an important part. Helm repo add EKS charts to add EKS into this cluster. It was successful. Then Helm install AWS load balancer controller within EKS / AWS load balancer controller -n namespace kube system. Set cluster name is resume cluster. Service account is false. Region is AP South 1. Then I pasted the VPC ID. Within this VPC ID equals the thing I copied, VPC ID. Then it was successful. We can see that it is deployed, and we can observe that AWS load balancer control is installed. Then I performed Docker login GSR, that is GitHub Container Registry, to access and create secret for private GitHub container registry of my application. So I performed this command, that is docker login ghcr.io -u username, which is my username, Kaif Mohammed Khan of the GitHub, -p with the token, which is personal access token, and it was successfully logged in. Then I created the secret, which is GHCR secret, which is specified in the deployment YAML file of my application resume matcher in private GitHub container registry. I confirmed it with kubectl get secrets. We can observe that GHCR secret is successfully created. And one more thing is that I would be adding or creating secrets on the fly, meaning it is creating secrets on the runtime, not like I have this YAML files and I'm applying it, create secrets, which is not a best practice, meaning your YAML file would be exposed and there is no point of having those YAML files as secrets. So instead, I performed and created secrets using commands and the CLI on the fly in the runtime, so it is secure. Then I confirmed the kubectl pods within the kube system namespace and to check if load balancer is up and running. We can observe that pods of AWS load balancer controller are up and running, which is 2 pods. Then I confirmed if AWS EBS CSI driver pods are up and running or not. So I performed the command kubectl get pods within the namespace kube system, which is app.kubernetes.io /name equals AWS EBS CSI driver, which is for persistent storage for database. You can observe that EBS CSI controller pods, EBS CSI nodes are up and running. Then I applied the storage class YAML for EBS storage. I performed kubectl apply -f StorageClass.yaml. We can observe that StorageClass.storage.kts.io /gp3 is created, meaning EBS volume is created. I confirmed it with kubectl get storage class. We can observe that gp3 ebs csi.aws.com is successfully created. I confirmed it with kubectl get pvc -n namespace default. We can observe that pg data Postgres 0 status, that is bound. We can observe that storage class, which is gp3, which matches what we have created in the YAML as well as in this storage class command. After storage class and persistent storage was successful, I created all other secrets which was required to access my application, which was database secret, API key secret, and CXID secrets. I created all those secrets within the runtime and on the fly. After those secrets were successfully created, I applied all other YAML files by kubectl apply -f dot. So all of those YAML files would be applied at the same time. Then I confirmed the pods by kubectl get pods. We can observe that required pods are up and running, meaning Postgres, which is database, which is up and running. Resume matcher GHCR, which is deployment pod, which is also running. I checked the services by kubectl get svc. We can observe database is of ClusterIP, Postgres is also of ClusterIP. Resume matcher service is of NodePort, which we have specified in the service YAML file. Then I confirmed the Ingress, which is kubectl get Ingress. We can observe the resume Ingress, which is of the class ALB, and we can also see the address of it, which means it is successfully created. We can observe the address, which is kts default resume in and this path within the region AP South 1.elb elastic load balancer.amazon aws.com on the port 80, which we successfully managed to create Ingress with ELB elastic load balancer within the NodePort service for internal communication. Then I head back into the security groups of nodes and I exposed the required ports to access my application. So I edited the inbound rules and I added the required ports, which is 31173, 3000 to 31173 within all over the internet. Then I saved that rule to have exposed ports to access the application. Then I head back into the CloudFront and I created the CloudFront by the name ResumeMatcher, and with that ALB Ingress address, I created the CloudFront distribution to access the application on CloudFront. I created all this configuration on CloudFront by adding ALB address. Then I copied the distribution domain name, which we can observe here. I pasted in browser and we can observe that the application is successfully up and running. I added the resume and I searched it for the results to see if my application is even working or not. As we can observe, the application is successfully up and running with the results. Then I confirmed it with the logs. I performed kubectl logs -f with the logs of the pod ResumeMatcher GSCR. We can observe that Google API key, which is required for my application, is loaded. Environment Kubernetes Postgres SQL, which is also loaded, and it is saying the application is up and running with the status 200. So I successfully managed to create the EKS cluster. Service type was NodePort. It was accessible on CloudFront via the application load balancer of AWS. I also managed to create persistent storage by Elastic Block Storage EBS CSI driver. So that is it for the video today. If you have any questions, you can let me know in the comments. Thanks so much. Have a great day. Bye.